So, persevere. This is the client-side JavaScript persistent object mapping framework that I've developed, and this kind of actually represents the the official release of the beta version of Persevere. So I'm kind of now making it available. So, but Persevere is this framework for being able to map data from persistent data on a server using the JSON protocol and mapping it to your client-side JavaScript. Some of the things that it includes support for is orthogonal persistence, which means that you don't actually need, if you turn on orthogonal persistence, you don't actually need to call a save or anything. It's just you set properties and forget it, and they're automatically saved to the server at the end of whatever your current event is. And so it's automatically kind of wrapped in an implicit transaction around whatever your current event is. It has lazy loading capabilities. If you reference a property that hasn't been loaded yet, it'll transparently request it from the server, and then block execution while it's waiting for the response, and then resume execution. And it also implements JSON RPC, and it actually kind of implements a kind of an extended version of JSON RPC. So JSON RPC, if you notice, it's actually procedure calls. It's not object-oriented. There's no target this object. And so this, because Persevere is dealing with persistent data, and you can make references to data by object IDs and so forth, we can actually do like true method calls where we actually reference an object to be this, and we can pass around object values and so forth. So we can actually do real method calls. And one of the cool things about that is we wouldn't have to actually have a specific servlet that does branch logic. We can make method calls on existing objects in the persisted data storage. And then it implements an open API for persistence.
So I'm sorry.
Mm-hmm.
So Persevere is some kind of a JS include
Yeah, exactly.
that allows you to.
Mm-hmm.
So it's basically whatever was underneath the tool that you just showed us.
Yes.
Okay.
Yep, that was built on Persevere.
Okay.
Exactly. Yep, good question. So here's some example usages of it. Here's an example where I load an object by an ID. And it's potentially supportable that you can do a query depending upon what your server supports, and you can get a result back. If the result's an array, you can, like, let's say we did a database query, so we returned a result set. So this would map to an array, and we could just use it like normal arrays. We have this object that we got back from that array. We can just use normal property references. So it's just normal object mapping. If we want to make a modification to the data in the persistent storage, we just set a property and it gets saved. It uses normal JavaScript methods, so I can do a result.push, and push is kind of like add for a list in Java. It just adds an item to an array. And so I could add a new object to it, and then that would be like adding a new row in whatever my persistent data is. I can remove objects from the array. So one of the things that's cool about this is all the things that we didn't have to do. We didn't have to call do Ajax, and we didn't have to create a request controller, and we didn't have to serialize and deserialize our information. We didn't have to write SQL. And there was very little API in that. All we had was that PGS.load, and all the other stuff was basically just regular JavaScript. And so I think that's one of the power of this, is that we can just use regular JavaScript and do fairly complex things. One of the things I was going to mention is there is another persistent object mapper in JavaScript called Jester. And one of the things that it's perfect for is if you're a Ruby on Rails developer. They follow the active record paradigm, API, and everything almost perfectly. And so if you're used to Rails and active record, Jester is a great choice. So I'm going to talk about some of the things that Persevere can do, though. One of the things, like I mentioned, is lazy loading. It can automatically wrap things in transactions if the server supports transactions, and it's all wrapped around wrapping things around events. And it's designed for being able to do things like optimistic locking, merging, putting correct timestamps on objects and when they were modified, so the servers can do arbitration around locking. And then once again, it has support for doing auto-saving, and so so that you can basically do set properties and forget it. The persistence is orthogonal to what you're doing in JavaScript, and it also has integration with, if you guys recall, in the last talk I talked about JavaScript strands. So it has integration with that whole continuation framework, and that's how it actually uses, does lazy loading. It'll suspend execution using it. Actually, I haven't integrated with cross-save yet, so I'll just remove that.
If you have a different object graph because you have, lazy loading and stuff, so one guy here has a different graph than what you have over here, where do you do your logic for optimistic transactions right there?
So the way that works is basically, whenever I make a modification on an object, and I send that request for a modification back to the server, I give it a timestamp of when I received that object. And so that allows the server to say, okay, actually that data has been modified since that timestamp.
You have to refresh your object graph on this side.
Right. Well, I mean, and if it doesn't get refreshed, if I make a change and you make a change, and you send your request into the server, and I send my request into the server will be able to look at the timestamps, and it'll be able to look at my timestamp and say, oh, that timestamp comes before the modification request that you sent in. And so it's then able to arbitrate and say, whether it can decide whether it wants to reject my modification request, or maybe it can merge those. Maybe you change one property, I change a different property, so it's like, oh, okay, that's fine.
But how does it handle when you both?
If you both change the same property, the JSON protocol doesn't define that. This is the client framework, so that's up to the server implementation.
Okay. So, I thought you wrote that. How do you
Well, I do have a server implementation too.
Okay.
And right now it's not very sophisticated on how it handles. If you both modify the same property, it would just, whoever's new this, it would win. So it's kind of naive right now. But it provides all the information so that servers could create a more robust technique, either rejecting the modification or trying to merge it.
So how is that normally handled then?
Normally, the most persistent object, normally it's rejected. If you make a modification and the server, the controller, or whatever, knows that another modification happened between the time you retrieve the data and you make the modification, it usually rejects it. It's usually concurrent.
Some kind of concurrency exception or something like that.
Exactly. That's the typical way to do it. But it is possible sometimes, depending upon the data, to merge changes. So. Okay, and so the server implementation that I built. So this is a server-side implementation of JSON, and so this is basically kind of like an object server. And when I did that little demo of the object graph browser, and I made a modification, it was sending a request to the server, and the server is just kind of an autonomous unit that you can build these objects in, make modifications to, and it's just all going through JSON. One of the things that it also has is it's built around Rhino, which is the Java-based implementation of JavaScript, and so one of the cool things you can do is you can actually have methods executed on the server in Rhino, in the JavaScript environment in Rhino. And the cool thing about that is since we're using persistent data, we can basically be talking about the same objects effectively, right?
Whether you're on the client side or the server side.
Exactly. Exactly. And so that's really cool because I can have a method execute in my server environment, and it's acting effectively the same, dealing with the same objects, same values and everything as it would on the client. They can have a high level of interoperability. We can make distributed calls. I have a little